the new better technique that we are going to do is we're still going to use the end behavior and the x and y intercepts. If you have the x and y intercepts and the end behavior, you can get a very accurate graph of what's going on. The y-intercept is going to be super easy. I suggest always finding that first, because all you have to do is plug in 0 for x, and usually that's really easy mental math. Trying to boost my self-esteem at this moment. Get 0, 0. The x-intercepts you have to get by factoring, because we have to make y equal to 0 and factor. Now, if I make y equal to 0, in this case, you can factor out a common factor of x, which then gets you to the quadratic, which you can factor quickly as well. X minus 3, x plus 2, and so we get, I almost forgot the equals 0 here, E2 error. X equals 0, x equals 3, and x equals -2. Hello.
Is Arlie here? Right there. Oh my gosh.
X equals 0, x equals 3, x equals -2. The end behavior of this one, you see that this is an odd function with a positive leading coefficient. So there's our end behavior. I would lose marks on this graph right now because I haven't labeled. So I would have to label 3, 0 to give some sort of scale. And if I just put like a 2 there, I now provided scale on my y-axis as well.
Should it be x-intercepts at x equals 2 and -3, since...
Did I copy something down wrong? Oh, there's a plus sign there. And then I just miraculously made that into a minus sign? Thank you. So yeah, this would be, if this was a plus sign, that would change my factoring. Thank you. To +3, then a -2, which is -3 and a +2. Sneaky. Okay, wait for it. Does that look like a 2? And that one I could do better. That one managed perfectly. What happens when you scroll down and can't see the original question anymore? Now, if the end behavior has to start down here, we would go through this point, curl through here, curl through there, and it has to end up there. This is our graph. All polynomial graphs have smooth curves. If you draw your graph with any sharp point, sharp enough that if I touch it, I could cut my finger, I have to take off a half a fork. So if your graph was like, oh, I'll just go, yeah, ouch. And I have to take off a half point. It needs to be a nice smooth curve all the way through. So if you have your x-intercepts and your y-intercepts, okay, first of all, the important thing is you find all of your x-intercepts. So once you found your x-intercepts, those are the only x-intercepts. You can't invent new ones. So if your graph decides to go through the x-axis again, you know you've made a mistake. Now we're also going to do in this question, because did you see how easy the factoring was on this one? What's going to happen more likely is you're going to get factoring ones like we did in 1.2. So let's do let's just walk through the one they gave as the main example as well. Okay? And behavior. You see this is an x to the 4, positive leading coefficient. So there's our end behavior. This value of -6, that's your hint. If we can factor this, it could possibly be 4 things. And all of the last ones would have to multiply together to get you a 6. So your options are plus and minus 1, plus or minus 2, plus or minus 3, and plus or minus 4. I would use the remainder theorem with 1. So I would say I'm going to try f of 1. Since it's f of x, I don't have to say let p of x, because it's already labeled as f of x. And you would get 2 minus 1 minus 14 plus 19 minus 6. And it works out so nicely to 0. This tells us that x minus 1 is a factor. If we want to factor it, we're going to have to use synthetic division. Coefficients, everything's in the right order, so make sure you're double checking that. Dividing by x minus 1 means positive 1 out front. Bring down the 2. Multiply, add, multiply, add, multiply, add, multiply, and add. And sure enough, happiness, we get a remainder of 0, which is what it should have been. And we can now write the division statement. Careful with your division statement that you make sure you write an equal sign. F of x was our function. X minus 1 was our divisor. Our quotient is going to be 2x cubed plus x squared minus 13x plus 6. And we still have an x cubed. Okay? So sometimes I do this. I'm going to just call that part p of x. I'm going to cheat a little bit, because I would normally look at the 6 and try plus or minus 1, but they don't work this way. I'm like, then I would go to 2. Oh, I think p of 2 equals 0. We'll double check it with our synthetic division. So now, synthetic division with this. 2, 1, negative 13, 6. I think that p of 2 equals 0, which would make x minus 2 a factor, which means I'd put a positive 2 out in front. Bring the first number down. Multiply. Add. Multiply. Uh-oh. This isn't going to work. Oh, did anybody see my mistake? I did it on purpose. Anybody double check? What's 2 times 2?
4.
Oh. Okay. 4. And add. Multiply. And add. Oh, good. It worked. Now, this, I could write a division statement for p of x, but I want to, notation-wise, and this is why it's a good question to do this one as well, I want to write, I'm factoring f of x. I know that I have x minus 1. I now know that this part has an x minus 2, and I'm left with a 2x squared plus 5x minus 3, which is now a quadratic, so I could factor that. 2x and x. You make the outside 3, the inside 1, outside 6, plus 6, minus 1 would give me plus 5. Double check, the minus 1 plus 3 gives me the minus 3. This works out beautifully. And if you set this equal to 0, you have 4 x-intercepts. X equals 1, x equals 2, x equals 1/2, and x equals -3. Did I get excited about factoring really early, or did I? Oh, I did. We've got our end behavior. Right at the top here, it's really easy to find the y-intercept. Can you see if you plug in 0 for x, you're going to get -6 as your y-intercept. So now that you have all of your x-intercepts, and that y-intercept, and the end behavior, we can draw a really accurate graph. Y-intercept at 0, -6. X-intercepts at 1, 2, 1/2, and -3. I could label the other ones, but it's obvious from the graph where they are. End behavior, was it positive x to the 4? Yes. So we have to start on the left, it's going to go up there. Okay? Now, I'm going to show you, don't jot this down when you're doing bright yellow. Okay? I'm going to show you what is a normal temptation for students. And this, I'm going to have to blame your grade 1 and grade 2 teachers. You are just used to connecting the dots. Okay? So, what's the problem with connecting the dots? Well, right, you might get a sharp point there. I cut my finger on it, and then I have to take off a half mark. It's supposed to be a smooth curve. So you're like, okay, well, what happens when I connect the dots with a smooth curve? Whoa! You can't go back in time. There's another common mistake. Okay? So sometimes, even though this is a dot, this does not necessarily mean that's going to be the minimum. You're so used to just connecting the dots that you will naturally want to just go to this one. But if I'm drawing a smooth curve, you see how it's probably more likely something like this? And in grade 12 pre-calculus, we're not too concerned about where that minimum is. We leave that for next year for calculus. But for right now, that is what would allow me to draw a smooth curve. I don't know how high this went, or maybe that goes further down. We're not concerned about that. We could get an idea if we did a table of values, like you could plug in 1 and plug in -2, -1, and maybe -1.5 and get an idea, but we just want to draw the smooth curve through all of those points. Those are the only x-intercepts you have. So you can't go, ooh, I want to go around again and up again. No, that would create new x-intercepts. That's not allowed. Okay, so questions for practice after number 2 are 7 and 13. And you'll get more often ones that you actually have to factor to find the x-intercepts. So this is our improved strategy. Finding x-intercepts and y-intercepts and using the end behavior to graph.
How did you usually get 4, positive -4, or the -6 on top?
Which -6 are we talking about?
That,
This y-intercept part? Oh, all of, yeah. At the 4, it makes no sense. You're right. It's supposed to be 6. Because you're just looking at factors of that last one. When we go down to our factored form, notice that all of these last numbers, when you multiply them together, they make 6. All of your first numbers multiply together to give you 2x to the 4. And a whole bunch of stuff happens in the insides and the outsides and a whole bunch of arrows for all that other stuff. That's a little bit too complicated to see right away from the beginning. So, next, before we get to the last question, I'm going to give you one to think about. Let's say I gave you an x cubed graph. Maybe it was a 2x cubed graph, but somebody spilled coffee on and you don't see the rest of it. And all of the work in between was gone, but you could see their graph. And on their graph, they labeled an x-intercept there, an x-intercept here, and a y-intercept there. And this was all the ones that they found. Well, because it is a 2x cubed graph, you go, well, I know it has to do this for my end behavior. Okay? Right? There's my end behavior. How is this possible? I would have to start down here, right? Okay? I have to go through this one. Okay? And then I have to go through this one. And then I have to go through this one. How did I do? Seems okay, except what did I do? I invented a new x-intercept. That's not allowed. We're assuming they did this right. They found all of their x-intercepts and all of their y-intercepts, but we just drew it. It seems impossible. Can you draw it so that it has the right end behavior, goes through those points, okay, but doesn't make it, like I just made a new x-intercept. Okay, let's erase it. Start again. What do you think?
Couldn't you just make the first x-intercept just be the very top of that curve?
Ooh, like that?
Yeah.
Does that work? It does. Okay? We are going to call this a bounce. It's not a mathematical term, but it just describes what happened. Do you see it sort of bounced off of your x-axis? That's going to be our official term. If you put bounce on the final exam, they will give you full marks. Just saying it bounces at that point. They'll be like, okay, I get that. And this is related to, I should have started this on the next video. You'll find out about this on the next video.